Hello, hello, hello. All right. There you go. That's the whole talk. We made him dance, guys. All right. Can I get everyone's names real quick? Yeah, what's your name? Okay. Patrick. All right. We're going to have a couple demo sessions here. It'll be fun. Hello. This is a talk called How to Make Your Robot Dance and Do Other Stuff Good Too. I am hosted here with JC Leone.
Hello.
Motion capture expert and entertainment connoisseur. This is a little bit about me. You getting any audio from the presentation? Let's go back. You good on audio? Oh, here we go. So, I'm Mitch. I'm a creative technologist. Went to, guitar camp and film school and ended up becoming a developer. This is the banana drum machines, which was my shtick in college. So I would teach DJs how to program and students how to build their own MIDI controllers. So if you like coming from this sort of physical prototyping, that's sort of the basis of robotics these days. So in this case, we have a makey-makey with 5 bananas, and then you tap the banana, it sends an electrical signal to your computer, and then you get a sound. And if you like that kind of stuff, robotics is actually in a really cool spot for that. So I'm Mitch. I run a studio called Experiential Technologist out of Austin. We do creative rapid prototyping. Feel free to catch my email if you want to shoot me questions about all this. Here you can see me accidentally launching the karate move in front of a bunch of people and holding the robot back. Great time. Also, somebody jumping over the robot with a skateboard. Very cool use cases for robotics. This is a bit of a smorgasbord of what you can do with a humanoid robot. You can use it as a prop for cool videos. It's a great attention grabber. You can have it on stage to dance with the band. And you can run what are called custom policies. So in the same way you load songs onto your iPod, you load policies onto the robot. And the policy is a machine learning file that governs how the robot moves. So in this case, that is a spin kick. Over here on the right, you can see the simulation on my Dell workstation guiding the robot to do that double spin kick. I have been kicked by the robot at that session. There you go. You can run an LLM on the robot. You strap a webcam and a speaker and a microphone, Wi-Fi. It'll walk around and roast people.
Oh, darling, being roasted by a robot is the 3001 version of a spa day. I'm just here to help you feel fabulous and outdated.
Can you give me a high five, Frodo?
Oh, a high five? Sure, but don't take too long. My circuits are buzzing in anticipation of your fashion choice.
So, this is a great use of LLMs. The interactive sensing of the world, the interactive generation of text and responses. You'll see a lot more of these interactions going away from chatbots and into physical devices like this. So for better or worse, that's what's happening. And I think it's up to us creatives to actually get some good personality out of these guys. Yeah. So you can see here it caught her hat as part of the camera.
In 3001, we just think the text and it appears.
There you go. They just think the text and it appears in 3001. So that's good prompting. This lady held her phone up.
Camera in my face like I'm a celebrity. I see you with that pink swirl phone case. What, you steal that from a toddler?
So it's pretty good. The prompting is good. The imagery is good. The interaction really makes it interesting. Something else you can do with it is kind of turn it into a big Roomba. So this is autonomy mode. Basically, there's an open source package called OpenMind, and people build backpacks for the robot. So this is an NVIDIA Thor. And then this allows it to kind of walk around and map the whole space.
Running on the back, and I have no control over the robot right now. It is making its own.
Yes, I am fully autonomous and ready to explore with you, Mitch.
There you go. So right now, This is the property I've been at with the first two robots I've been working with.
So on the G1, you got a LiDAR and a depth camera,
right
and a
now,
magnetometer, IMU, gyro,
robot
all the
is-
fun stuff that actually lets it sense the world. In the same way that a Waymo figures out where to go, this will actually figure out what obstacles are near it and then path plan.
Pictures of what's in front of it.
So path planning looks a lot like this. You can see the LiDAR scan in the background, and then this red ball was the target. So it actually somehow figured out how to navigate around the stage case and walk to the red ball. But that's what it's seeing, quote unquote, right? But to this day, the best use case of a humanoid robot is falling over on stage for a video. So this was at a grad party at my alma mater, where I was hired to, you know, have it on the dance floor, and it crashed into a table. So these things fall over all the time. It's like buying a Lexus and then running it into a wall. If you are curious about what a robot is like, it's very expensive, and well, I'm more worried about the concrete in the table than the robot though, so it's very sturdy. I went to Dell Tech World, which was a lot of fun. So these things are great at events. You've probably seen me running around here. That's robot on the floor, robot standing, robot roasting Michael Dell the whole time I was talking to him, which was funny. This is kind of what that looks like. Oh, back. See if the video plays. Oh, hold on. This is not robotic error. There we go. So, dancing robots attract a ton of attention. It's kind of like putting a Cybertruck outside of your law firm with your number on it. It's got like 4 or 5 built-in dance moves, so you guys have definitely seen the same moves over and over again. And, you know, it's really fun to show this at conferences because people love it. It's also fun to like back it into people or get really close, and just most people have never interacted with a robot in a nightclub or in a, you know, any kind of like general setting. So this was it at the Dell Tech World Convention, running around, hugging YouTubers, stepping on toes, doing karate. And what was funny is at Dell Tech World, Ludacris performed. So the first night at Dell Tech World, I met their team. And then that turned into this. An entirely custom dance move for the Unitree G1. So they sent me a video of somebody doing the dance. I texted that video to my Dell workstation. The workstation processed the entire pipeline, sent me back remotely the policy through GitHub. And again, I'm in Vegas the whole time. I'm like running a show. So this is what it looks like to actually train a robot to do a custom dance move for somebody like Ludacris, right? Just insane. So to get this working while I was not at home with any of the safety gear that I have, I was in the back of the Las Vegas Convention Center a month ago trying to get it working, and I did, and then that's what it looks like, you know? It's just, all these custom policies are so finicky, but once you get it working, you think you're good, and then actually getting it on video is the hard part. So sometimes it just falls over. So to show you what a policy from the factory looks like, this is what like hundreds of PhDs and machine learning engineers have deemed worthy of being released as part of the actual firmware that comes from the robot. So this is like the Jeet Kune Do from Unitree. This is what they ship with the robot. If you've seen it doing karate outside, that's what it looked like. So there's this journey of like, okay, I have a robot. How do I make it do other stuff? Because clearly they have. So you start with something like this. This is a move-in 3D motion capture camera, markerless. And this is Jasmine. She's a dancer. This is Mike, he's 86, showed up to do karate. And so we captured them doing a ton of moves. And that's what this looks like, right? You start with the mocap, You get the data out of it, you add the physics in to train the policy and simulation, and then the robot can actually do that dance or that move. And it's a whole trial and error thing. So G1 Moves is an open source package of policies and data that you can download right now without a robot if you want to get started with this pipeline, right? All of this is open source. I've created this data set of new dance moves for you guys to try out and train. And as long as you have the right hardware or a laptop, good gaming GPU, you're good. So we're gonna dive a little bit into what this looks like. So these are just some of the moves. We'll let this cycle through. And so you can see here the difference between the green motion capture data and then the robot actually trying to fit that data, right? It's not doing it accurately because it's trying to stand up the entire time. So part of this process is actually using generative video or smartphone video as well. So this guy, this box right here, what is that, 10K?
11.
11K, right? But you don't need it. You can start with just your phone or generating video.
Yeah.
So in this case, video to robot, you can upload your smartphone video or generate a video, and it'll actually extract the motion from that video. So that's a pretty good use case for generative videos.
Yeah.
Generating human motion that doesn't exist yet. So here we have a group of women dancing. Now you have 5 robots dancing. It's the ultimate replacement for TikTok dancers. So, quick 5-step pipeline for how to make your robot dance. This is the meat of what you guys came to learn. First, use your phone. Do your dance. Get it nicely framed. That's all you need to start. Video to robot is the repo where you'll then upload that and then get just the motion capture motion out, right? Which is damn cool, but it's not everything you need. From there, there's an open source package called MJLab, and MJLab lets you bake it, basically. So that spins up 100 million robots on your GPU, and 99% of them try to do the dance and then fall over. And eventually it gets to a point where the robot in simulation can do the dance without falling over. And then from there, you have what's called a policy, right? And that's sort of the cookie that you bite into to see if it actually works. So once you have that policy ready, you can use Robo Judo on this actual robot right here to deploy it much like you would an iPod, right? You play music back on your iPod, you can play policies back on the robot using Robo Judo. So this is what a shuffle dance looks like. We had Jasmine record a shuffle in real life. This was the raw data that came out of it. We retargeted it to the robot, so it's just taking that data and putting it on a 3D model. And then this is what the policy for the shuffle looks like. This is with the added physics of the real world. That's what makes it different from gaming or film. In this case, we also had the single ladies dance. You know,
Single
it's
robots.
got some hip action.
Single
Got some hip
robots.
action. So this is called sim to sim, right? Where you go, this thing works on my computer in 5 different places. Let's see if it works in the real world. So, as you can see, getting this thing to work on the actual robot is a lot of trial and error. Playing back that same dance move on the robot, I use a gantry to hold it, so it's a bit safer. And, you know, it's able to get it. There's a reason you have the gantry. There's a reason I don't do custom dance moves around people. But you can see it kind of got the shuffle, you know?
Yeah.
It's going.
Yeah.
And then, you know, here's the single ladies.
Yes.
This is where you can really see the why you have a gantry involved in robotics. So.
It's like after a couple drinks, maybe.
Yeah. It's very violent. So as somebody that's been hit in the face and hit in the gut and kicked in the leg and pinched, be careful. This is what 100 million robots on your GPU in simulation looks like physically. So it's literally just spawning a bunch of 3D models of the robot, trying to get them to do that dance move. And then the ones that fall over are marked and then say, we're not doing this anymore. That's how the reinforcement learning works.
So interesting.
There's also a new paradigm in robotics of LLM-generated code to get the robot to do a dance, right? So this is a little bit different than the policy. NVIDIA CapEx is a simulation environment where you can prompt 5 different models and then see which one writes the correct machine code to make in this case, make the robot arm unplug itself. So this is an example of LLM-generated code for an art installation I did, where we have the robot arm plugged in by somebody, and then it'll do a little dance and then unplug itself. So ignore me on my floor, but
Unplug itself. So I will have this barrel jack mounted about here. Somebody will walk in, plug the cable in.
and again, this is all generated through an LLM, but it's machine code, so it's actually scripted, not a policy.
After booting up, flail around existentially.
So
Look around at the
the
audience.
robot's supposed to flail around once you plug it in, looks around, and then it
come
goes down and
grip the jack,
grabs the jack and
and then
dies.
kill itself.
So, great use of AI. Always make sure you have a roaming pasture for your robots. And the last thing you can do is make 1 million robots fight themselves in simulations. So, every robot comes with a 3D model. You can pop those into a gigantic battle simulator. And that's how to make your robot dance and do other stuff good too. So now we're gonna dive into the workshop here. G1 Moves is free to download. If you got, Windows, Linux, may or may not work on your Mac. This is totally fun. No robot required. This is the hardware I use. I am gracefully sponsored by Dell Technologies, so everybody say thank you, Michael Dell, for bringing Sparky here. Take a picture of this. This is all the repos that you would need to kind of reproduce what I've been doing. This is also available on the website, and we'll get into that in a second. Let me know if anyone's done. Okay. And then this is XPT. This is my brand. Call me if you need me. I do a lot of wacky tech stuff.
Yeah.
And now I'm going to kind of dive into our showcase of the moves. JC, why don't you talk a little bit about Mocap?
First thing I just want to say that there was just so much amazing stuff there. I think the evolution of robots has been so fascinating, just because at first it's the curiosity of seeing how they move, what they can do, if they can tell you apart from others. And for me, it was the robotics of as a kid, just like little toy robots. I've been rigging and motion capturing for about 20 years now, and it was more of like making these robotic characters on the computer. So first it was building controllers so we can make it move. Eventually it was about using motion capture.
Right.
So the motion capture system I'm going to show you is a fairly new system. So really what I want to tell you is how much robots evolve. Same thing with motion capture, same thing with animation. So in the past, you'd had to wear like suits. You had to wear little sensors to track someone, little balls. You see it a lot in the Hollywood films. A few years ago, I started working with another company that did markerless motion capture as well as moving. So this is all AI-based. So what's cool about this one in particular is one camera. It's like a LiDAR camera, just similar to what you would see in a Waymo. And if you stand in front of the actual, let's say the space that I'm in here right now.
You can see this.
You can see it here. There might be a little bit of a glare. But what's cool is that it can recognize me right away, and I'm able to start doing my motions and dancing. So what's great about this type of technology and how it's evolved is it allows any user to come in and instantly be tracked, instantly be recorded. So the evolution of motion capture is awesome because I see the future of gamification with motion. Like right now, we're so used to using controllers, maybe some, like a headset to connect to an experience, right? But really, and even with your iPhones or your phones, like you scroll up, you scroll down, you do these things. So everyone in society has gotten used to using their hands and fingers for gesturing. With motion capture, I look at it in the future for gamification or robots, is a full body gesture. It'll probably be a uniform way of starting a game. Think of it this way. You clap, you do this, you do that. So you're learning how to use your body with that. But what makes this great with the relationship with robots is that it's using AI to estimate where it thinks you are, right? it doesn't really know because it doesn't have the dots like we talked about earlier. It doesn't have the markers or the sensors, so it's estimating. Sometimes there's multiple cameras that are tracking and estimating. Once that estimation is calculated, it says, okay, I think this is kind of what you're doing. Similar to with the robotics, you can take this data and apply it to a system, like an amazing robot here. But at the end of the day, this robot's still a physical, motorized object, meaning that it still needs to balance. So if I was to do like in my move, I started to do something like this, and I'm thinking, okay, this is great. I know how to balance really well. I'll be fine. I want to put it on my robot. But just like Mitch mentioned earlier, there's ways of like kind of blending them together.
Even for teleoperation, which is where you wear a VR headset and then it uses your hands to actually operate the robot arms, that's going to be the biggest use case of both VR headsets,
Yes.
AR headsets with monocular cameras, and systems like this where you can guide a robot arm to show it what to do, and then machine learning training after that to get it to continue to do that.
Yeah, I mean, I think it's so fascinating with the robots. I mean, like, first it's like, just seeing it move was great. You've seen tons of videos of them falling, like he showed earlier, which were awesome. But the customization is actually fascinating. I mean, everyone here most likely probably has a PC, a personal computer. There will be a world, I like to think, where there's like a personal robot. But it could be intended for good cases. It could be, it's just depending on how you do it. But I think as creators, people that are interested in it, it's a matter of diving in, seeing what you can make out of this, and finding unique kinds of experiences, so then as people we can enjoy it and feel comfortable around other robots and not feel scared.
I mean,
right?
These things are super creepy. It's a gigantic metal drum toddler, basically. You know, it's so this is called a velocity tracking policy, which is where I provided a joystick input on something that's effectively a PlayStation controller. And then it translates that velocity, you know, left, forward, back into bipedal movement in the same way that, you know, pressing gas on your car makes it go forward. So I'll get Sparky out here, and feel free to come check it out. We'll say hi to Charlie. High five. Oh.
Yeah.
So yeah.
Yeah, I was gonna say, you know, you were talking earlier about how you can customize a lot of these things. I think that's where I'm excited about it, because you have seen a couple of dances that you have, but you can imagine if you had a certain themed experience that you wanted people to experience, and being able to build a database of moves is very fascinating. So that's where I feel like the mixture between motion capture and robotics is a thing. It's like a new relationship. You're like, wow, I didn't know how well we can work together. And I like to think it's like an ecosystem that it's still fairly new, because I think a lot of people I've met that have been really into robotics don't really touch the motion capture side or the maybe like the other creative side, but they're codependent. So having a way to kind of learn both is going to give you something where you're kind of the glue between both kinds of workflows.
So now we've hit the surprise for JC, where he has to dance against the robot and see who
For
wins.
my life,
So,
yeah.
JC, go ahead and give us a move.
Okay. Let's see. I'm gonna just do this.
Okay. Everyone, clap for JC.
All right. Yeah. There you go. Well, I'll just do like this.
So again, these are all really complex movements, and this the policy is what's keeping it standing right now. Because you can hit this thing and it'll fall over, but if you push it a little bit, JC, can you wiggle his shoulder? Yeah. So like, you know, right now it's actively maintaining its balance, right? It's not just standing there. So if I like back it into JC a little bit, see, it can take a little beating. And so what we want everyone to come do is check out G1 Moves on the internet. There's a ton of different dance moves on the website. If you search G1 Moves Hugging Face, you'll find it. And then you can click on View. Those of you who are devs will be able to figure out how to download it. There's a whole bunch of info. All the repos you need are right here. And so everyone can come form a line now and try out JC's motion capture system.
Oh, yeah. Feel free.
Like. So come on down. Who's interested in capturing a dance move? Yep. Okay, well, that's pretty much the talk. Any last quick questions?
Yeah, I was wondering, so you showed you record a video, you process it, all that stuff, and then how does the robot account for different surface types? So this is different than a wood floor versus a marble floor versus ice.
slickness and, you know, shakiness. So that's all policy training.
Shuffle would be harder on a carpet than it would be on
Yeah, that's all policy training. I'll answer questions after this. I think it's time to wrap. But thank you guys all.